Very well. So how do we calculate surface area? Suppose you have a function like f of x. This is your function defined on an interval a to b, and it is positive function, and the derivative of the function, first derivative of the function, is continuous. Now suppose you take this function and start revolving the graph around x-axis. That's how you generate the surface of revolution. Remember that for volume, we revolve a region. For surface area, we just take a curve and revolve the curve and define surface area or surface of revolution. The idea is the same. What do? We take the small piece of this function, this curve, and then we actually calculate this area, add them all together to find the surface of the revolution. We're going to use our right triangle Pythagorean theorem to find the length. You learned about the length, how to calculate the length, and you're going to use that. All the proofs are written here. The surface of revolution follows the formula, the integral a to b 2 pi times f times the length of your function. So this part gives you the length of your function. 2 pi times f is related to this part of your surface. If you're interested in the formula and how we drive the formula, here's the detail for you. The idea is exactly the same. You have to apply mean value theorem, factor out delta x to create the derivative of the function, and this is your surface of revolution formula. Let us go over one example. Suppose you have graph of this function 2 square root of x, and it's defined on an interval 1 to 3, and we're revolving that about x-axis. What's the area of the surface that's generated by this revolution? Very well, we have a nice formula. We know that f of x is 2 times square root of x. We have to take the derivative of the function and raise it to the second power and add 1 to it. The derivative of this function, to take this derivative, let us write the function in the format of 2x to a half. So you get 2 times a half x to a half minus 1. So you can cancel out 2 and 2, and you get f prime of x equals to x to negative a half, which is 1 over x to positive a half, or the derivative of the function is 1 over square root of x. Very well. So when you raise the derivative to the second power, you get rid of absolute value and get rid of square root. So here you get 1 over x, 1 plus 1 over x. You can take the common denominator between these two. Let me show you the detail. Here you have square root of x times x plus 1 divided by x. Here you can cancel out these two, and you end up with square root of x plus 1. Very well, Here we can use u sub. You can take u to be x plus 1. Du is equal to dx. So you get the integral of square root of u du, which is equal to 1 over 1 plus a half u, or x plus 1 raised to 1 plus a half. So this guy is equal to 1 over 3 halves, 1 plus x to 3 halves. You have to multiply it by 4 times pi. So 4 times pi times 2 gives you 8 pi divided by 3, and you have 1 plus x raised to 3 halves. You plug in 3, you plug in 1, simplify to get the surface of revolution. Let us continue. Surface area of spherical zone. Suppose you have a spherical zone which is produced when a sphere of radius A is sliced by 2 parallel lines. Okay, here you have a sphere and you slice that by using 2 parallel lines. We want to compute the surface area of spherical zone that results when the first plane is oriented vertically and cuts the sphere in half, while the second plane lies h units to the right-hand side. And suppose your h ranges between 0 and a. Very well. First of all, what is this function? Remember that you have x squared plus y squared equals to a squared, which gives you your circle. So y squared is equal to a squared minus x squared. So y is equal to square root of a squared minus x squared. This is your function. Very well. We have a nice formula for our surface. To calculate that, we have to take the derivative of this function. The derivative of this function is equal to, first of all, you have exponent a half, so you get a half. The derivative of a squared is 0. The derivative of negative x squared is minus 2x. And then here you have a squared minus x squared raised to a half minus 1, which is negative a half. Now we have to raise the derivative to the second power. Of course, you can cancel out these two. You get negative x raised to the second power, or x squared. And here, when you raise this expression to the second power, you get a squared minus x squared raised to negative 1. Very well. Now, inside the radical, you have 1 plus x squared divided by a squared minus x squared. If you take common denominator between these two, a squared minus x squared, you get a squared minus x squared plus x squared. You can cancel out x squared and x squared. That's how we get this quantity inside the radical. And remember that in your formula, you have 2 pi times function f of x. Your function f of x is defined as square root of a squared minus x squared. So when you substitute that, you can cancel these two expressions. The outcome is equal to 2 pi integral. You're just left with a dx, because the square root of a squared is a. The integral of a dx is ax. When you plug in h, you get 2 pi ah. Okay, perfect. Last example, example 3. Suppose you have the curved surface of a funnel, which is generated by revolving the graph of y equals to x cubed plus 1 over 12x on interval 1 to 2, and is generated by revolving it around x-axis. Perfect. So we have to follow our formula to find the surface area. 2 pi f of x, square root of the derivative of the function raised to the second power. So the derivative of x cubed is 3x squared. The derivative of, let me show you here, the derivative of 1 over 12x. First of all, you can write 1 over 12 outside the parentheses and just take the derivative of 1 over x. This is equal to 1 over 12. Here you have x to negative 1, the derivative, or you can apply quotient rule. You get 1 over 12, negative 1, x to minus 2. So if you simplify this, you get negative 1 over 12 x squared. So 3x squared minus 1 over 12x squared, and we have to raise this to the second power. Let me show you the detail here. Very well. We have square root of 1 plus, you raise 3x to the second power, which is 9x to the fourth. Then here you have minus 2 times 3x squared, 1 over 12x squared, plus 1 over 144 x to the fourth. Okay, so as you can see, here you have x squared and x squared. You can cancel out these two. Here you're left with a half, so you get square root of 1 plus 9 x to the fourth minus a half plus 1 over 144 x squared. 1 minus a half gives you positive a half. You get square root of 9x to the fourth plus a half plus 1 over 144 x squared. If you complete the square, you get square root of 3x squared plus 1 over 12x squared raised to the second power. That's where this guy coming from. Then you have to multiply this by the function itself, and you can write 2 pi outside the integral. Note that you have square root of exponent 2, so you can cancel out these two. Now you can distribute x to the third into parentheses, then you can distribute 1 over 12x into parentheses, plug in 2, then plug in 1, and you get your outcome, which is this ugly number here. Since the paint layer is 0.05 centimeter thick, the volume of the paint needed can be found by multiplying your surface area and 0.05.